Matos, is everybody ready for Days of Science from Mexico? Mexico now. Let's get to science talks right away. It will be awesome time every day. Everyone around the world can have their say. It's ICPS. It's time to share your great knowledge of the science. Is everybody excited for this conference hosted by Mexico? Mexico now. Let's get to science talks right away. It will be awesome time every day. Everyone around the world can have their say. It's ICPS. ICPS.
Yes. Okay, so welcome everybody. Welcome to our next guest speaker. Sorry for the couple of minutes. We had some technical issues. You know how it is. But if you don't remember me from a couple of hours ago, my name is Lamborghini Sotelo. I am the general coordinator of the International Conference of Physics Students, Puebla 2022. It's a great pleasure for me to introduce our speaker today, who is going to talk to us about a brief history of physics in Mexico. Dr. Tonatiuh is member of the Dark Energy Spectroscopic Instrument, DESI, and the Event Horizon Telescope, the EHT, collaboration. In 1992, he served as a founder, vice president of the Division of Gravitational and Mathematical Physics of the Mexican Society of Physics. 3 years later, he functioned as the president of the same division. He served as the president of the Mexican Society of Physics until 2021, that's last year. And in the areas of scientific dissemination, he's been an organizer of 37 national and international conferences in gravitation, astrophysics, and cosmology. As a guest speaker, he's been part of more than 150 conferences, of which 50 have been international. And in scholarly subject, he has supervised 16 doctoral theses. 2 of them got the Arturo Rosenbluth Award and the Weizmann Award from Israel and the AMC. For the best doctoral thesis. Also, their PhD students have supervised 30 PhD theses, 2 are Weizmann Awards as well. And without further ado, please join me in welcoming Dr. Tonatiuh Matos.
Thank you very much for the invitation. I was invited to speak about the story of physics in Mexico. I will speak about a brief history of physics in Mexico. I am not an historian. I am a physicist, but I have some experience on that. And I will speak about the pre-Hispanic, a little about the pre-Hispanic physics, astronomy, that was very important in Mexico. After that, I will speak about the independence and the current. And I will mix this current experience, or with this current story, with my experience. Well, as you know, Mexico have many cultures, and in order to understand what I am going to speak, let me say that the definition of science in science is the discipline we humans have to understand the universe. This is very important because I will speak about that. And physics is the science that seeks to find the rules, the laws that move the universe. That is very, very important in the next slices. Well, in that case, the observation of cosmos has given the way to do it. For example, do you remember how we obtained, or how Newton obtained the second law? It was because the experience of Copernico, and after that Kepler and Galileo Galilei, they observed the movement of the planets around the sun, around in our celestial void. And after that, Kepler obtained 3 laws. With these 3 laws, you can derive the second law of physics, or the second law of mechanics, the Newton. Well, therefore, it's very important to observe the cosmos. And today, we know that we have big questions, and the biggest question today in physics and in science is, what is the universe made of? That means we don't know how, we don't know the stuff of the universe. We don't know how is the matter in the universe. We know only 4% of the matter of the universe, and 26% is unknown. We call them the dark matter and dark energy, because we don't know what is it. Well, the observation of the cosmos will give doubtless in the future a new step, a new a revolution in physics and in science. This is really so. Well, let me start then with some of antique observations of antique civilizations. Maybe the first one I want to mention is the Teotihuacan. Teotihuacan starts before 200 years before Christus, and survived till 650 in our era. This is a very, very nice city. I don't know person who does not marvel at Teotihuacan. Everybody who visits Teotihuacan say this is marvelous, it's really amazing. It's a really very nice city. And the city is aligned with the cardinal points. It's almost from north to south. Here is south, and we are standing in north. That is the Sun Pyramid. We are on the Mount Pyramid. And all of this is the geometric, the knowledge of geometry and mathematics, calculus is obvious in all of the city, and is very remarkable. It highlights the aesthetic with which the city was built. Is really amazing. And of course, the city was built after the observation of the stars, because the alienation of the city tell us that this is important. The observation of the cosmos is important. Why we didn't know any else about that? Because everything was lost in a brand in Teotihuacan at the end of the time. And even when the Aztecs came to this part, of the Toltecs came to this part of the country, they found the city destroyed, and it remains only these monuments. Well, the second city, there is a funny thing. This is, in order to know how big is the Sun Pyramid, you see, this is the Cheops Pyramid in Egypt. They have almost the same size, not the same height, but the same size. The Cheops Pyramid is 230 meters long, and the Sun Pyramid is 225 meters. They are almost the same size and square form. Well, the other civilizations I want to mention is the Mayas. Mayas were amazing. The Maya calendar is a testimony to the efficiency of the Maya observers of the cosmos. This is a building constructed with the goal to observe the universe. Essentially, this building is constructed to see the movement of Venus in world year. The Mayas astronomers had a good systematic control of the equinoxes and solstices, and therefore they could measure very, very well the time. With these observations, the Maya's calendar was extremely accurate. For that time, they measured that the year was 365.2422 days. This is exact. Well, we know now that there are more ciphers, but for example, our calendar has 365.25 days. They have an error, or this so big as these 22 days. But after, I don't know, 100 years, this is remarkable. You can measure that very well. And with the Mayas, this measure, this accuracy was very, very exact. For example, they predict. This is the calendar. I am here in this Maya city in Chichen Itza. Well, we don't know how they do that exactly, because almost all the codices were burned in July 1562 by Diego de Landa in Mani. This is Mani. This is the church in Mani, and in this place, Diego de Landa burned all the codices. The codices were the papers, or the books where the Mayas wrote the knowledge of them and the observations of them. He collected, so Diego de Landa collected the codices through torture. He spoke with the Mayas and then tortured them and said, "Yeah, you have to give me this codice." And he collected all the codices, and in one day they burned all of them. Only 4 codices survived. This act is considered now one of the most barbarian acts in all of the history of the humanity, together with the burning of the bibliothèque in Alexandria in Egypt. Among many other things, 1,000 years astronomical observation were destroyed in this day, on this day, at this day. All we know now about the Mayas is from these codices, the 4 codices that remain, and the engraved stones or Maya stele. This is, for example, this one. This is a stele. This is a stone with these symbols, and the Mayas wrote all the knowledge of them here and the history of them here. This is, for example, the Quirigua stele, show the beginning of the Maya time in August 11 in 3114 before Christus. This is the Maya beginning of the time, and the Maya the Maya calendar ends in 2012, and they know exactly when in 24 December in 2012. Because this is an solstice, and the Mayas know that because the calendar were very exact. This is the symbol of the beginning of the time in the Maya this Maya Quiroga stele. Well, the steles predicts the eclipses. This stele, the Quiroga steles, predicts the eclipse of the sun on Friday, January 2, in 771 in our era. The Paris Codex contains the Maya zodiac. The Grolier Codex this codex is in Mexico. It's an almanac of the Venus movement around the year. And the most important codex, in my opinion, is the Dresden Codex. This is in Dresden, in Germany. I know this codex because I was living in Leipzig. This is very, very close to Dresden, and I was able to know this. Here is the almanac. This codex, the Dresden Codex, have on the other things, the almanac of the Venus movements. Here's this is collected here, the movements of Venus in each moment. But this codex is this one here. It's very big. Here's one part of this codex. Also contains various predictions of lunar eclipses. The problem is the following: if you take the knowledge of the Europeans in that time, they thought, or they have the model of Ptolemy from the cosmos. That means that the Earth is in the center of is flat and is in the center of the universe, and the celestial void move around our Earth, our planet, our flat surface. And this is the idea of the Europeans. And in the first part of the celestial void is the moon. After that is the sun, and after that the planets, and so on. And with this model, you cannot understand the lunar eclipses. It's impossible. We don't know how was the knowledge of the Mayas in order to understand the lunar eclipses. We don't know that. We know only that they could predict the lunar eclipses. So we conclude they have a model of the universe, a very advanced model of the universe in order to do that. They predict also some sun eclipses, which was really amazing. Well, this is this one city. This is Chichen Itza. The monuments and cities were built with a strong influence of astronomical observations. This is the pyramid in Kukulkan. The Kukulkan means feathered serpent, or it's a snake with feathers. During the equinox, this serpent is built here, and in order to do that, in the equinox at 12 o'clock exactly, in order to do that, we have to have this knowledge of the universe and this model of the universe in order to orient this or to put in the right direction this pyramid. Other thing is that this city has a strong influence of the Toltecs. For example, this is Maya. This building is Maya, but all of these buildings are Toltec, all of them, and therefore the connection between Toltecs and Mayas were very strong. Toltecs were here in Mesoamerica, here in the center of Mexico, and Mayas were in the south of Mexico. And you see here, the pyramids contain aspects of 5 engineering and calculations for the technology, for the technological innovations of the construction. For example, this Kukulkan pyramid is here, is over a cenote, a very big hole of water here. And then this is a building here, so sustaining this second building here. And in the third place is the building you see. This is the Kukulkan pyramid. In order to do that, you need to make strong calculations, and in the engineering should be very, very advanced. Well, the last, the other buildings with the technology and so on are in all of the cities in the Maya cities, in the Maya culture. Other culture, they inherited all the cultures of before, the Aztecs, Toltecs, and so on. They were the Mexicas in the center of Mexico. The technology and knowledge of the Toltecs and Mayas were taken by the Aztecs. The Mexicas, the important thing that the Mexicas have 2 schools, one for the aristocracy, and the name is Calmecac, and the other one is for the people, the normal people, the Telpochcali. In the Telpochcali, people learn, for example, carpentry, carpenters and stone workers and everything. And in the Calmecac, they learned the theology, philosophy, the philosophy of the Aztecs, and of course the technology and everything what they need for constructing these beautiful cities. Here's the city. You see, the city is here in the middle, in this island here, in this lake. The problem here is that this lake here is this part of the lake is salts, and this is sweet, and you don't need to, or you don't want to mix both. And in order to do that, they construct dikes and everything. And Tenochtitlan was built with the middle of the lake, and they showed great knowledge on hydraulics and engineering to prevent the flooding and the control of the rainwater. This is very important because the knowledge of them were very, very important, very high. Well, okay, then it came in Mexico, the conquest. The Spain come to Mexico, they conquest Mexico, and after that, we have 300 years colony time. It happened nothing because everything what happened in Mexico was actually happening in Spain. But in the independence in 1810, after the independence, Mexico has 22% illiteracy. That means 22% of the people couldn't. 100 years later, in the Mexican Revolution, in 1910, again, 1910, illiteracy was 22%. That means you have to start in the time when in 1910, in the time when the general relativity theory and the relativity theory and the physics and in the world was developed. In Mexico, we had 22% of illiteracy, and we have to start with that. My grandma told me that when she went to the school, they learned only to read and to write. That was all, and sometimes to calculate some very easy things, but no more, because it was impossible. There were no teachers. My mother, a little later, he couldn't visit the school for years and was old. And after that, she went to another school, but it was very difficult to visit the schools because there weren't teachers or local people that could learn, teach, for example, write or read or something else in that time. It was very difficult, very, very difficult, because the illiteracy was very, very high. Today, the illiteracy is less than 8%. It's not too high. And we have strong changes. Well, for example, modern physics starts I can say in 1942. because in that time was founded the National Astrophysical Observatory of Tonantzintla. I heard that David Hughes spoke about that in the previous talk. This was founded by Luis Enrique Erro. He was an astronomer in February 17 in 1942. Today, this institution is called the INAOE, National Institute of Astronomy, Optics, and Electronics. And this name was changed by Guillermo Haro in 1971. And therefore, we can say that this new institution, the National Institute of Astronomy and Optics and Electronics, was founded by Guillermo Haro. Guillermo Haro is an astronomer. He made his PhD in Harvard. Before he incorporated to this observatory in 1942, 1943, but in that time he came fresh from Harvard as astronomer. Well, today this institution, this National Institute, have the two biggest observatories in Mexico. One of them, maybe you have heard about it, is the millimeter grade telescope. Here is the biggest one in over the world in millimetric, and the Hawk telescope for cosmic rays. And it is for Mexico, it's very important, the cosmic rays, because we got a big tradition in cosmic rays, and I will speak about that in the next slides. Well, this telescope have, for example, these cameras, photograph cameras, the Toltec and the Aztec and other ones. And in order to see how big are these tanks, you see here the people who was involved in the construction of this telescope, the Hawk. They are very small in comparison of these tanks. Well. I have to speak about this guy. This is Manuel Salvador Vallarta, because he is very important in the history of the physics in Mexico. He born in 1899 and died in 1977. It's recent. Well, he born in Mexico City, and he's of course the first physicist, Mexican physicist in all over the world. He made the PhD in physics in MIT in 1924, specialized in Berlin and Leipzig in 1927. He visited courses with Einstein, Planck, Schrödinger, Heisenberg. You can believe it. It's very amazing. And after that, he came back to MIT, to Chicago. To Boston, and he was a young professor, later associated professor, and then full professor in MIT between 1926 and 1946. He published 60 papers on physics beginning and he began in 1932 to research in cosmic rays. And therefore, the cosmic rays are in Mexico very, very important, because the first physicist in Mexico was an expert in cosmic rays. He collaborated intensively with Mexican institutions. This is the reason why Salvador Vallarta is a very important physicist, a very important man here in Mexico. He's later, together with people in UNAM, he built the Faculty of Science and the Institute of Physics in 1938. In order to see that, the first professors here in these institutions were Alfredo Baños, the first doctors in physics, the first PhD doctors in physics. Alfredo Baños, he born in 1905 and died in 1904, and Carlos Gret González, they both graduated in MIT with Salvador Vallarta, of course, in 1937. They did research on cosmic rays, of course, and in Birkhoff's theory. Birkhoff's theory is a theory of gravitation, competing with the Einstein theory. Of course, Birkhoff's theory is now dead because it didn't work. But in that time, the research in Birkhoff's theory in Mexico was very important. Later came Marcos Moshinsky. He born in 1921, died in 2009. Started the theoretical physics and nuclear physics groups in UNAM. And this is the start of the physics in Mexico. And I will speak about the other institutions in Mexico at that time. For example, in Puebla or Veracruz or in other universities, but all of them were training teachers in physics. They didn't train PhD or researchers in physics. The first institution with that could have PhD in physics were the Institute of Physics in UNAM. Well, the other institution, very important institution, is the UAP, the Benemérita Universidad Autónoma de Puebla, the Autonomous University in Puebla. This school, the faculty in physics and mathematics, start in 1950, very, very early, almost in the same time as in the UNAM. The leading figure in this process was Luis Rivera Terrazas, an engineer, very, very high, very important. These groups began to make research in 1972 in low temperature physics. You see, they start in 1950, but the research start in 1972. And all of this time, they trained only teachers in physics, but the physics and the PhD and the real institution started in later, much later. The National Institute of Nuclear Research was founded in 1950, like in the physics in Puebla, as a National Commission for Nuclear Energy. Later, it becomes another name, the National Institute for Nuclear Research, and the idea was to build physicists in nuclear physics in order to construct the nuclear energy industry in Mexico. But due to the new anti-nuclear policies, this institution is dedicated to the attention of nuclear processes. Mexico has only one nuclear power plant and belonging to the Comisión Federal de Electricidad, the Federal Commission for Electricity. And after that, today this institution is only give only attention to nuclear processes, but they don't do actual research in nuclear physics because of the policy. Well, it was important to build that. Other important person who I want to speak with is this guy, Don Eugenio Méndez de Ocurro. He born in 1923 and died in 2015. I could speak with him several times. He studied engineering at the CIME with a scholarship from that time in Lázaro Cárdenas gave scholarships for engineers. And after that, he was very brilliant. He went to Harvard with another scholarship for the Mexican government, and he did the Master in Science in 1949 in Harvard. And then he went to Paris to specialize. There is a very funny history. He told us this history in a meeting that in 1959 he came some years before from Paris in 1955. And he remained here in Mexico as one of high qualified engineer. And someday, Jaime Torres Bodet was the Minister of Education in that time, asked him to visit the president because the president wanted to speak with Eugenio Méndez de Ocurro, with the Don Eugenio. They meet in the palace, in the president's building, and the president, that time was Adolfo López Mateos, asked him, Don Eugenio, I want you to be the next director of the Institute of Polytechnic Institute in Mexico. It was a very big institution that time with a big budget. And Don Eugenio told us he was scared. Said, "No, I am too young to do that." No, and Don Jaime Torres Bodet poked him so back and said, "No, you cannot say no to the president. It's impossible." And then he accepted the direction of the institute, the Polytechnic Institute, in 1959, and he was director till 1962. And that is the way they get the direction of this institution. He was very important because he founded the Escuela, the Escuela Superior de Física y Matemática, the higher school for physics and mathematics. He founded the Center for Research and Advanced Studies, the CIMBESTAB, the National School of, not the Centro Nacional de Cálculo, the National Center for Calculation, the Computer Science, the School for Biology, for Administration, and later he founded the CONACYT. So many things he has founded. It's a very important person in the history of science, Don Eugenio Méndez de Ocurro. Well, we are now in Polytechnic Institute. The first school in this institution is the higher school for physics and mathematics. The Center for Research and Advanced Studies, CIMBESTAB. They both were founded in 1962. And the first director of CIMBESTAB was Arturo Rosenblatt. Let me speak about this story because it's very funny. Don Eugenio Méndez de Ocurro, in one meeting, he told us that after he was the director, because he was obligated to be the director of this institute, the first he wanted to do is the school for advanced studies, or the school for master and doctors in the institute. And he asked the doctors in that time were very few people. For example, one of them was Leopoldo Garcia Colin. He came just from Maryland as doctor. He was very young, 29 or something like that, or 28 or something like that. And Méndez de Ocurro asked them, 5 or 6 persons to make the project for the School Advanced Studies in Polytechnic Institute. And that is the other phase of the story. This history, Leopoldo Garcia Colin told us in one other meeting in a table, so in a room table, he told us that he was asked for Méndez de Ocurro to do that, and they after work at 6 o'clock in the evening, they went all together to one place and worked and this thing 3 months long, till 3 o'clock in the morning. After 2 or 3 weeks, his wife asked him to divorce because she thought that he was with another girl. But after that, he convinced her to be that he was working actually. Well, after 3 months, they went to Méndez de Ocurro, and I remember that was December 29, December 29, 1961. And Méndez de Ocurro told them, "Okay, give me a couple of days, and I call you, or we meet again to decide how do we do that." And in first day in January 1962, they were called by Méndez de Ocurro after the New Year and to speak about that. And they say, "Okay, but we are all in the New Year party and so on." Now they have to go to Méndez de Ocurro, and Méndez de Ocurro told them, "Okay, I like the project, but who of you will be the first director of this project, of this institution? And nobody wants to do that. No, I am too young. No, I have to have many things to do. Well, one of them proposed that maybe Arturo Rosenbluth, he was a very, very high and very known biologist working in institutions of health in Mexico, and very, very recognized as a scientist. And Méndez Ocurro called him, and he came 2 days later and asked him, "Oh, do you want? Can you be the first director of this institution?" And Rosenbluth told him, "Let me think about that. Give me the project, and I give you an answer 2 days later." 2 days later, they meet again, and Arturo Rosenbluth told him, "Well, I accept to be the director, but I have 4 conditions. First one, this project, I don't like this project. I will do my own project for this institution. Second, I don't like bureaucracy. I don't want bureaucracy. Zero bureaucracy for my institution. Third, I want infinite money for books and journals. And fourth, I don't want that you be my boss. My boss will be the president, or maybe the minister of education in Mexico, but not you." And Méndez Ocurro told him, and saw him first, and told him, "Excellent, I like it. Go ahead." And this is the born of these 2 institutions. The Center for Research and Advanced Studies was founded by Arturo Rosenbluth, and the problem was they have worked, these 6 people have worked 3 months long for this project, and they had the project here. And then Méndez Ocurro said, why don't you use this new project for a new school, for example, the School for Mathematics and Physics? And this is the reason why they both born in the was founded in the same year, because this project was used to found the higher school for physics and mathematics. Well, then Arturo Rosenbluth asked Richard Feynman to be the first head of the Department of Physics in the new institution, in the Simvestab. Feynman thought about that and asked him and told him, "Let me think about that a couple of days." But after some days, they say, "No, it is very difficult for me to leave USA. But I recommend you Jerzy Plebanski. He's a very young very young man, and he's working in general relativity. I think it would be very, if he will accept to be the first head of the physics department in your institution." And that was so. And this is the reason why Jerzy Plebanski, and very known physicist, Polish, he came to Mexico, and he was the first head of the physical department in Simvestab, where I am working actually. And I was very, very strong involved with Jerzy Plebanski after that. He started research in general relativity in Mexico in the 1960s, and his first doctorate, he graduated the first PhD in Simvestab. The name is Bogdan Mielnik. He died 3 years before ago. And he remained in Mexico. He was also Polish. And that was in 1964, the first PhD in Simvestab, 1964. The first Mexican working in general relativity in Simvestab was me in 1987. And Jerzy Plebanski was the advisor of some Mexicans in general relativity. For example, Gerardo Torres del Castillo in Puebla. He is very important. He built the school in Puebla, and he was one of the first, or maybe the first PhD, Mexican PhD from Jerzy Plebanski, but in the 80s, together with Sabas Alarcón. Well, other institution that is very important is Guanajuato. The Center for Research in Optics, CO, was founded in 1980 by Daniel Malacara. And the Institute of Physics was founded in 1966 by Cliserio Alviles, but Cliserio Alviles died in 1990. And that was a very, very big problem. But Octavio Obregón and Jose Luis Lucio, Jose Luis Lucio was working here in Simvestab, and Octavio Obregón in UAM, accepted to go to this institute and founded again the Institute for Guanajuato. Now it's one of the biggest one in Mexico. Other institution is the Universidad Michoacana. I am speaking about some institutions, but please don't think that these institutions are the most important in Mexico. Now, I will speak about that in a moment, but you will see that it depends of the area of physics. You will see that this institution is important in different areas of physics. This school in Michoacan, it is another state in Mexico. The school today, Faculty of Physics and Mathematics started in 1970s. But as again, they all were training only teachers in physics, not researchers in physics. They began to make researchers or to train PhD physicists in 1992. The Institute of Physics and Mathematics was founded in 1992 and started to do that in 1996 with 4 professors: Antonio Nieto, Luis Villaseñor, Leonel Torres, and me. I was also founder of this first group of physicists in Michoacán. Therefore, I am speaking about that. Not there is another reason. Now, this institution all of these institutions have around 16, 20 researchers, and all of them are making research in different lines of different areas of physics. Many other important institutions. I will speak about one of them, or some of them. The UAM, the Autonomous Metropolitan University in Mexico, in the metropolitan area of Mexico, has a department of physics funded by Leopoldo García Colín, the guy who founded the Escuela Superior de Física y Matemática, the school in Polytechnic Institute. He founded this department in 1974, and it's very important. But in the 90s, the government began a new policy to decentralize the scientific research and higher education in all of Mexico. This was very important because before that, you see here, this is, for example, the first map of Mexico here is red. This is red colors and dark colors are because there are no scientists or no scientific evolution in these states. You will see the Mexico City was the only one with this is yellow. Yellow means many scientists. Red means no scientists. And you see, this is 1991, 2003. This is the second map, and the third map, 2016. You see, all the states in Mexico have now scientists and different directions of science. Many of them have physics. For example, Veracruz, the University of Veracruz, the University in San Luis Potosí, in Guadalajara, Sonora, Baja California, Chiapas, and many others. These are the most important. All of them began in the 90s. In the 1990s, and some of them a little later. Well, the evolution of the research in Mexico is also very, very interesting. For example, you see here the evolution of this institution. This institution was founded in 1994, because in 1984, because in 1982, it began a very, very strong economical crisis in Mexico. And the salaries of the scientists were down. Many of them abandoned the universities, the research, and went to other branches. For example, here in the Department of Mathematics has 3 very important mathematicians. one of them is Solomon Lipschitz, other one is Samuel Hitler, and the other one is Adam. And Adam, Solomon Lipschitz returned to Israel. He was Jew, and Hitler went to USA to USA. I think to Rochester as head of the mathematics department in Rochester, and only Adam remains in Mexico, but died very, very soon after that. And then the mathematician group, the high mathematicians group in Simbestad was died in that time. But they create the national system of researchers in 1984, and this alleviate a little the problem. And you see here the evolution of this national system. They start with in 1984 with 1,300, almost 1,400 researchers, and today in 2016 it was 25,000. Today we have 35,000 researchers in this system. It's very hard to enter to this system because you have to show real, very many publications in very hard, very important journals. In other words, you cannot enter to this research system. And we calculate that there are the double, also twice the number of the researchers in the system are making research in Mexico. There we have almost 70,000 researchers, 60,000 are working in physics. The problem is that the budget of this for all of these physicists, of these scientists is getting lower and lower. You see here, this is the evolution of the national product in cooperation with the investment in science. This is the evolution. You see today we have 20.29 almost the percent of the national product of Mexico investment only in science. This is too low. This low in comparison. You see here, for example, Korea invests 4.5. Japan 3.3, Germany 3.1, and we invest 0.3. That means 0.3% our national production. This is very, very few, and almost all this inversion comes from the government. In other countries, the inversion comes actually from the industry. Well, let me then conclude from this history. You see, Mexico is a very, very young country in modern science, in modern physics. Science, in particular physics, is too young in modern Mexico. We need to multiply the number of researchers by 15 or 17 in order to have the enough amount of researchers. For example, Germany, I know Germany because I studied in Germany, have almost 400 researchers per 100,000 inhabitants in Germany. Mexico, I said 400. Mexico has 30. Compare 400 with 30. Maybe you can say, okay, you take all the researchers in Mexico into account, and this is maybe 40. But not, we need 400. For example, Japan has 600 researchers per 100,000 inhabitants. This is really amazing, but Mexico has, Latin America has no researchers. We have to improve that. We have to multiply by 15 or 17 the number of researchers in our country. And we have to reach at least 1% of the gross domestic product in science, the investment in science, if we want to be, or if we want to have a real transformation, or real transformation, like we are saying. There is no other way to do this. This is no other way. Please take that into account. If we don't improve the number and the investment in science, Mexico will remain as a third world country. Thank you very much. Questions?
So thank you very much, Dr. Tonatiuh. It was an amazing talk. I think it was very interesting. Before I start talking, make sure to ask your questions both on the chat. We have the chat here on the Zoom, or if you're following on YouTube, you can pose your questions. We'll be reading those. Or if you want to open your mic to ask a question, you can also ask for that. But yeah, thanks a lot for the very interesting talk. I think it's amazing how you showed from the very beginning of the history how this ancient civilizations had this incredible knowledge about astronomy. And it's curious because I did my bachelor's in physics in Mexico, and you see all this astronomy, and I never understood like why was astronomy so big and not like a different field. But yeah, I think we have a couple of questions coming up. Question from Fernando Flores. What do you make of the current president's position about not wanting nuclear bomb makers and thus reducing science research budget? So this is kind of political, but yeah, let's go for that.
No, yes, this is a world's politic. In all over the world, you see the Greens, or the people who defends the nature, fight against the evolution of the nuclear research and nuclear how do you say that, power in the world. For example, in Germany, they decide to stop all these research producers with nuclear power in 1930. Today they are thinking about that because the war in here in Ukraine, and they are not getting gas, and this is the problem, and they are thinking about that again. But they will stop all of these nuclear powers in the 1930. The only country all over the world that is continuing constructing these installations is France. Only that. All of the other countries are trying to stop that. And Mexico was also in this politic in the 80s, 1980s, and therefore we didn't develop that. No, we will think about that again, because many of the technology is new. The technology has advanced in great measure, and we see that in the future we can control of these dangerous things in these machines. But I think it is a topic of the politicians more than the physicists, but it will be important. Yes.
All right, thanks a lot for the answer. Fernando also thanks you for the great coverage about the prehistoric astronomy. Says it was great. We have another question from YouTube. Besides investing in science, what other activities should the government do to increase the quantity of scientists in Mexico and Latin America?
Well, the first thing we have to do is to change the politic, because the reason why is the number of scientists in Mexico is not increasing is because the politic is wrong. And I can say with my without I know that without doubt that this politic is wrong, because Mexico is not advanced enough, because we don't have the technology we need to do better instruments, better technology, and so on, because you don't have the enough science, number of scientists. This is the problem. And in the 80s, and in the 90s, and at the end of the last century, the politics was right. And the number of scientists were increasing very, very fast. But suddenly they stopped that actually in 2000. They stopped that, and there is something a statismus in this direction. And first, we have to change the politic, and second, we have to increase the budget, the financial support to the scientists, and slowly that has to roll up. In 2004 or 2003, something like that, the laws changed, and in the constitution in Mexico, is written that the investment in science should be 1% of the national production, and no president have accepted that, and the investment is 0.3, 0.92, 29, 0.24, and something like that. It is amazing why they did that, or they do that in the present regime. It is the same, and the politics is wrong again. We have to change the politicians to have new politicians that think in another way, and then increment the budget in science. And then Mexico will change. We'll have the fourth transformation they claim.
Okay, thanks a lot. We have a follow-up question, maybe the last one, from Cesar Martinez. Cesar, do you want to open your mic for that, or should we read it for you?
Yeah, hi, good morning. First of all, thank you for such incredible speak, because I wasn't aware about all the background from Mexico. Since it was a nice talk. So my question is, what do you think is Mexico is missing to increase the number of scientists? I mean, you already talk about the budget, but is there any other factor that affects the lacking of scientists? And also, similar to the first one, what can we do as a young scientist to make a more scientific country?
For the young people, first I have a very good news, especially for physicists. The good news is that the physics is now taking a revolution, and it will come a revolution. It is doubtless so, because of all of these questions we have, because the evolution of the technology has permitted us to observe the universe, to observe the micro world, to observe many things that we didn't do that before. For example, the new telescope, or for example, the new microscopes, or for example, the new experiments doing quantum mechanics are amazing. This is really amazing. We didn't dream about that. But when we see that now, it's just really surprising what we are doing, what we are learning about the observations. And for the physicists, the future is really amazing. I think without doubtless, I think that this is the best area, the best time for studying physics in all of the history of the human, of the men, really. This is the good news, and the bad news is in Mexico. The politicians are not helping to do that. Now in Mexico you can do research. There are many groups. They are very important. They are making good research. They are publishing in the best journals in the world, in all levels. Yes, and the quality is really very high. It's enough. It's incrementing. It's increasing, but it's enough today, and it will be better in the future. I can say that without doubt, really. But we have to change the politicians. Politicians are really very real. I don't understand how we have to have these politicians. And I don't speak about these politicians now. I speak about the politicians for 20 years before and 25 years before. All of them have no vision. The vision to increase the science in Mexico. And all the countries in the world that have increased the scientists are now very rich. For example, Korea or China or Japan. All of them are rich because they invest in science and technology. This is no other way to make better Mexico. Really, no other way. This is the only way. No other way. Thank you.
All right, so there you have it, guys. Start talking to your politicians wherever you are. That's the most important thing, because these are the guys that are making the decisions. So with that, we will finish the lecture by Dr. Tonatiuh Matos. Thank you a lot for coming. Thank you. If we receive more questions, we're gonna send them to you so you can answer, and then we'll pass them on to the students. For now, I'd like to invite everyone to join Gather Town. You should have the link to the icebreaker activity, so you can start meeting all the people and students from around the globe. So see you there in a few minutes.
Thank you.
Bye.
Bye-bye.